This comment is just not correct. Definitely not correct. Yeah. I post money. Yeah, I gave up with going to bed early and then laying awake 4 hours doing other stuff. I might as well code the part of that time. I'm not sure about this comment either. Well, this comment is correct, but yeah, the comment is correct, I guess. What? Root graph tracker. Root graph tracker can be null here for some reason. Let's add that. That's correct. Okay, let's say think. Let's say there is factors and arrays. There's no difference between them. Moving and copying, there's no difference in this regard here. So I'm having to do with constructing an item. It's not even allowed really, I think, but okay. Can construct an item passing a root graph. Let's call it T0. I could construct an array of items, some size, some index. Which I think requires a root graph and then has an initializer list, which can also be nothing. I don't think it should not pass root graphs here, so that would look like that. I guess I can construct an array from, actually D0, is that a root graph or is that a parent graph? It's a root graph, right? Root graph. Yeah. I could, of course, construct something from an existing item, say I1 or I2. So this is an item that does not get past the root graph. This is an item that does get past the root graph. This is an item that is an element of array. which gets constructed without passing a root graph, but the array does get pass a root graph. This is an array that constructs elements by copying them. And then we can copying them from all of the ones that we already have. That's array 1, array 2. So we could also copy, let's say, from array 2 first element. Any element actually, but well. That's already a copy constructor. The items I end up with are either in an array or not in an array. So this is not in an array and this is in an array. When that is not in an array, there's three possibilities actually. I pass a root graph or I don't pass a root graph. And the last option is I just copy it from an existing one, which then I guess still can be the ones that we had before. One of the ones that we had before. And can I also pass a root graph to... I don't think I can pass a root graph when I copy something. Let me have a look at item. I don't. Hey, little Dick. Yes, it is happening. No, it's 0:30 here. It's 1 hour later where you are. Item. I don't even see a copy constructor for item. I want to make a list of everything that's possible within reason, you know. But I'm not sure if I can pass also a root graph here. Well, of course, I really should look at actual examples like A. Well, this is a copy constructor. And then the question is there a copy constructor for A that also allows me to pass a root graph? Nope, I can pass a what? Extra, but not the root graph. Nothing is derived from rectangle node, so maybe I was just lazy and didn't add that constructor. But the label node has it. Copy constructors with a what argument? So no root graph. Copy constructors. Move constructor, root graph. But that doesn't copy anything, so no, it's not possible. Unless I got lazy and didn't add it here. If node doesn't have it, then it just doesn't have it. It's the last thing I check. Node is an unlocked tracked object. which doesn't know anything about root graphs. So yeah, forget it. Well, that would then be the locked node. So yeah, we have a move constructor, a copy constructor with a what, a move constructor with a what, and a root graph, but not a root graph plus a copy. That's just, we don't do that. Good to know. So relying on my past self, it's amazing. So we could copy from the I1 or I2, and now I have everything that is possible that is not inside an array. Next thing, I'm going to put it in an array. Then either we can construct it like I1. I'm not going to construct it like I2, although you could do that. Yeah, I just shouldn't. I mean, I could construct it like this, you know, the same way that I2 is constructed here. But that is just silly because you have to pass it to the array as well. Let's check that. Because now I'm not even sure about that. If I create an array, do I always have to pass a root graph? Let's see, we have an initializer list that does take a root graph here. You can pass a root graph without an initializer list, but no root graphs when you copy or move, and also no initializer list without a root graph. So it's pretty complete, and then it's of course silly to pass the root graph here as well. So let's not just never do that. And then we have a 2, which is copy constructing. So that's, this corresponds to that. You know, I1 is created from nothing, it's a default constructor. Here we use the default constructor. This we don't do for the reason that I just said, just silly. And I3 is copy constructed from I1. That's what we do here. And I4 copy constructed from I2. That's what we do there. And then we have all possibilities. Except, of course, that we can also copy it from an element that is already inside an array. And then you've got to ask yourself if I have to copy for myself as well. Must be a limit somewhere, but hey, why not? Let's be complete. I'm going to create another array where each element is created from the elements of array 2. That's array 1. From array 2. Array 2, 2. And I could keep doing that, but I'm not. I think that should be enough. And then we have the possibility to copy the whole array, right? So we have an array, so array 4, which is copied from array 1. Yeah. Unfortunately, it's ridiculous, but true. Copy from arrays, and in this case we cannot pass a root graph. I just looked at that. It's just copy. Move is different, but it's the same. So let's forget move constructors. Just look at copy constructors. Okay, I think this is like everything that we can do. If all of these work, then it just works. And now I want to think hard and write down what I think should be the root graph for each element, for each item. And in order to write that down, I'm going to have to specify them like, say, item 1, other items. And here I have item 1, item 2, item 3, other items. And here we have item 1, item 2, and other items. And here I can't do that, but we also have, of course, 3 items. No, array 1. It's only one item, basically. This one, only one that is relevant. That one has 3 items, and that one has 3 items. And let's say item index 0. Index 1 and index 2. And then index 0 is the only one here, and then we have these 3 also there. New column, zip. Now we have a root graph and we have a parent graph. If I would construct an item just like that, then we don't have a root graph. It's just no root graph is specified. Oops, what the hell happens? Undo, redo. Oh. Another redo. That's clearly null. It's not null pointer. I just type null because we don't have a root graph. And we also don't have a parent graph. And I want to test it. So now we go back to the test. And I'm creating here a single item. Now I cannot construct an item, but we can construct an A and call that item 1, because the A is constructed from a rectangle node, which is a label node, which is a node. Which is an unlocked tracked object, which is an unlocked, which is derived from log node. Log node is an item template, and the item template is derived from item. So it's an item, right? Like literally derived from an item. So this is my item, and I don't pass anything, and then what happens? That is the question. Well, I do want to recognize it, so I'm going to set a label on it. Item 1, set label item 1. Does not compile. Wow. No matching function equal to, oh wait, yeah, A has no default constructor. Well, whatever, pass something. What? No matching function equal to A int? Oh, we must pass the water also. If I turn off the WOT, then we don't have to do that, of course, but it's gonna, you can pass an int, but that also demands that we pass a WOT string. Well, just for debugging, so we can do that as well. This is item 1. It's the same as the label, I guess. Why not? And the result is not visible. There is no item 1. So what happened? Literally no item what even added to the graph. So now I can run this thing in the debugger and see the obvious. I always like to do things that are obvious and then do a next little step. And then what used to be obvious is then, you know, not what was added. So it's easier to recognize the difference. So I'm going to do main run list. Use next until I get to a item constructor here per asset label. Okay. Print item 1. So yeah, label is item 1. The root graph, these are the things that I'm interested in. The root graph is null. The parent graph is also null. So, okay. I can live with that because I didn't pass anything. And this must work. And it was super trivial. To be expected. I expected it. That was template, right? So, where are my comments? I thought it was an item.h. Now I don't know anymore where I was. It is an item.h. Oh, I called it I1. Dude. Here are my comments. And null is correct. Okay. Now the next one. I2. Well, let's construct this as well in the much the same way. Do I want P, and the difference is that it is called item 2 with a WOT of item 2 and a label of item 2. And more importantly, I'm now passing the root graph. How do I pass the root graph? I already have 2 arguments. Struct A. Root graph is entered after the int. Okay, so you're going to pass here G0. That's item 2. Item 2 test. Make. Item 2 shows up. So the fact that it shows up means that it has a parent graph, and it is almost impossible that the root graph is then not also set because we passed the root graph. So I think that what happened is that we passed the root graph, and then it thought something like, wait a minute, I'm just constructed and I don't have a parent graph, which means that it would not be visible. Let's add myself to the root graph. Which is kind of what I want, I think, because as far as I know, I have only a root graph, so everything here is, the whole white surface here is the root graph. And the only reason it's not in the root graph is when it is in another graph, a subgraph, and the only subgraphs that I have are either a class, so when it is a class member, or, well, other obscure reasons, so I cannot even remember them, but it's definitely not something allocated in the main, constructed in main is just in the root graph, period. So that's correct. So if we debug this, break a main, run, next, create item 2, print item 2, and then we see that the root graph is that, and the parent graph is also set, and they are the same, and that is G0. G0 is, nobody knows. Well, it must be that, so probably this. Tracker, graph tracker, okay, whatever. No, I want to edit item, yep. So the root graph is G0 and the parent graph is G0. Now we copy I1, which doesn't have either. So trivial, right? No change. I mean, it just it wouldn't know how to get G0 even, so it must be 0. Must be null. Let's do both at the same time. I'm gonna guess that this one is just copying everything from I2, so that's gonna be G0, G0 as well. Let's do those two. So we do I3 and I4, and I3 is copied from item 1. Oops, no int of goes, just copy. And I don't think, I don't even want to look at what happens if I pass a what, I think. Because I'm more interested in obscure copies somewhere inside internally. So I'm going to use the real copy constructor here. And here we have item 4. Which is copied from 2. The result of that is that, yeah, 3 is not visible because it was copied from 1. 1 is not visible. 3 is not visible. And item 4 is indeed visible because it was copied from item 2. I mean, it's hardly necessary to run this in the debugger, but I'm going to do it anyway. Break main, run, create everything, print item 3, and indeed, I say before I even looked, 0, 0. And item 4 is the same value even. Like before, so they are the same, just G0 again. Okay, so next we get, finally it gets a little bit more interesting, just a little bit. Now we are going to create an array with a default constructed thing. I think that works. And this item should have a root graph, G0, and a parent graph. Can you guess? Null. That's what it should have. So let's test that word. Let's call that just array1. What's with all the spaces? Oh, that was my prediction. Never mind. Okay, let's make this just one element. Which is it going to be an anomaly? I'm not sure. A index. Just make two of them, I guess. Okay, that's array 1. Label array 1, and probably needs a what as well. Now we can see here how to do that. Not going to keep it, so I might as well type the comma myself. Just like comma what is being expanded, expanded, yeah. Array 1 is a what. That should compile. I hope. Shit. Oh, I know why. I'm an idiot. I've got to construct this from an integer again. So let's do here array. The what is the first element of array, and this one. Okay, let's make it 3. Although I'm really only interested in the first element, right? I just added this second element, so not something really strange would happen, but I cannot imagine that is the case, but anyway. So it's the same constructor for A. Still doesn't work. Now what? Now what? Required for. I had the feeling that I forgot to replace item with A. Because that's all it said. Yeah. No, it's okay. Finally, it's okay. Right, this compiles, and then if we run this, we get array 1. And since we passed, we said that when we used a index, it's also added here. So we see the 2 elements here. And the fact that we don't see A42 and A43 in the root graph, it means that it doesn't have a parent graph. But got to debug it, so let's make sure. Run this in the debugger and then break main run. Next. Create the array. Why the hell are we now at line 326? Okay, set label. Print array 1, and I'm only interested in the first element, right? Oh, thank God, I was right. The root graph is set to God knows what. And the parent graph is not set. That's a value I didn't see before, so what the hell is that? Hopefully still G0. Yeah, okay, G0 just moved to somewhere between runs. Good. So far so good. So in this case we get G0 null, and that's how it should be, I think. Yeah. At some point we're going to get something that is not how it should be. And that's the harder part, because then I have to figure out which is right, my program or me. Rather, I have to get it right without that the program tells me. That's what I meant. Array 2. Well, that's quite interesting, because I think that it doesn't matter how I construct these things or from where. Just the fact that they are array elements means I want them to be G0 null. Which is quite an insight, because then everything else below here can be filled in. These are all elements of an array. Yeah, actually, I think that's kind of correct, right? This is what it should be, just everywhere. There is no reason not to know what a root graph is, because we even pass it to the constructor. And as soon as the parent graph is set, it pops up there. And I don't want it to pop up because it's an indexed array. So this is just what it should be. Delete, print, 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 print. Print. So probably not worth making this ASCII art thing. Might as well just delete all of this. Certainly those, you know. I mean, it's just everything, every element must be G0 null. I'm not sure if this works already. Hello, MT kiddo. Is that a goodbye, or it was a goodbye? He left. I want to do this one, which copies from I1, I2, and array 1. Here on 0. Okay, I should be able to remember this. Let's try to remember it. I1, I2, and array 1, 0. Yeah, I was going to use copy constructor. Sorry. No new what does the copy constructor. So item 1 and item 2 and array 1 0. No, can't you do that? That's the whole point of the array. It doesn't accept integers, so we have to use I begin for array 1, for example. Integer begin, so that's the index of the first element of array 1. And then it compiles, and then we do that, and now we see a lot. Is this correct? I see here the array, item 1, item 2, and a copy of first element of this array. And item 1 is not, I don't know, man. Looks not correct because this one seems to be added. I don't know what the difference is with the previous picture. We made a copy of something. Was that item 2? I could use some arrows now. Not sure what is what belongs to what. Let me try. Let's just run it in the debugger. I'm going to just print that out. Break main run. Array 2 0. Yeah, the root graph here is set to the only graph that we have. That must be the root graph. Must be G0. I mean, print G0. That's the root graph. And the parent graph is null, and that holds for all elements. Unless it's this element. Okay, so we have a breakage here. This should be null, and it isn't. On this one, it's also, there's two things wrong. Second and third element are not correct. Second and third element, that would be item 2 and that should be a copy of array 1 0. Well, I didn't see that one. Definitely did not see that one. Oh wait, the what is updated, the label isn't. But yeah, these are just these two here. So item 2 and A42 have a parent graph equal to the root graph, and therefore they are visible here. But they should not have been here. They should not have been here. These also should not have been here, by the way. This is the same artifact. This is a ghost image, let's say, of these three. And those two of these two. Only item 2 and item 4 should be here. That is correct. And this item 2 is therefore not equal to that item 2, but the label corresponds because we copied it here in the array. But this one should not be here. You should be able to see the what in the dot file. Yeah. So I have a normal item 2, and we have an item 2, and this is the copy of a copy of item 2. Actually, it's a copy of that, which you also see here. Is that true? No, that's item 4. Probably got copied twice then. Must be this one. So apparently I copied it twice. How inefficient. This is even worse. So that one should not be here, but in the end it is a copy of a copy of a copy of array 1. First element of array 1. Yeah, horrible. So now I can mark that this one fail, and this one is fail. Meaning that parent graph is set, right? Okay, I'll just write that down here. Just actual result that we get is twice G0. Well, let me do A3, array 3. Yeah. There's A3. It's kind of clear that they are put in the order in which we are created. So this goes wrong for all three items. It seems. And we copied element by element from array 2. So this is array 3, it is array 2. It's a perfect copy, but all items are now appearing here in the root graph as well. Good. Or not good, but I understand what Spock would say. So vi item.h. I'm gonna assume this because it's just what it is. Everything else fills as well, I bet. Copy of array 1. That might actually work still. I'm not sure about this one. Okay, I'll just fill them in completely. 0 D0, this is a fill, D0 D0, and now we have to do all these three. Let's create an array 4, which is a copy of array 1. Array 4. It's a copy of array 1. It means I'm not passing a root graph anymore. Let's just copy array 1. Number of elements of array 1 is 2. That's how it worked, right? Copy constructor of graphviz array. It's just probably just const reference what. Use what we do have a normal const reference. I don't. Yeah, that's what I was doing. Not passing. Sorry. Like that. Just copy it. Okay, there's my copy from that. Here's array 4, and they are both failures, so they are both visible. Definitely a fail. And I really don't have to try these tiers. These are just all failures. Array 2 was already fail. Well, okay, array 2 is not completely a failure. This is going to be fail. This is 3 fails, and this is also going to be 3 fails. I'll just have to check it, I guess. Array 5 is 3 elements. I said 3, why is there 4 here? And this is a 5, and this is a copy of 2. And then array 5 sets a label of array 5. And now we have what I wanted. Shall I do the other one immediately as well? Array 6, copy of array 3. Array 6, 6. So yeah, 5 and 6 both have all 3 in the root graph. So all of them are fails. That's a lot of failures. Hmm. Yeah, I guess I go to bed. At least now I know what's wrong and I have a test case. This not the test suit. I could maybe make a real test suit for it in the sense that I just suit assert, aka automate testing the parent graph. Not sure how I can do that though. Parent graph is stored where? Here, it's protected. I guess I could use these accessors here, which are public. Not this what I need, or this. Graph red. Yeah, so I want the parent graph to exist. No, I don't. Sorry, the opposite. I want it to not exist. Dang. Well, okay, that's item. Hmm. Yeah, I need to access the object. Read access the object locked in node. So wouldn't that just be node rot? It's not this, maybe unlocked. Yeah, of course it will be a rot, yeah. So I need node rot, level node rot, rectangle node rot, a rot. It's as easy as that. Hello, Jeffen Puroginach. Well, I'm coding something difficult. Coding something that does this. Makes a graph. There's no edges yet, but you see lots of junk here already. It makes a graph of all the existing objects in my program. Oh my god, now I forgot what I was doing. I just said it. Nope. It's gone. It is totally gone. Oh, right, I know it again. Soon I will not be able to remember it anymore. And then it's just really gone. That's really bad, man. Then end of my life. So what I want to do, I think, is create a rot object. And that would be item 1R from item 1. Let's see if that even compiles. You see that bloody compiles. So it's right, or it's right. And then we can assert that item R. Well, actually, this is nonsense, but okay, let's test it on this one. No, it's nonsense. Let's go to the array immediately. 2dd. Array. Here's my first array, array 1. So we construct the read access type from, let's call it array 1 index 0. Read access type, and then I construct that from the first element of array 1. Yeah, I'm just going to do, I think I can construct explicitly an A index from an int. Why the hell is that red? Totally correct. And then this gives me a pointer access to the underlying node, aka I should item, aka I should get here parent graph tracker, parent graph tracker. I think item.8 parent graph tracker. See, and then you can just test the value of that, of course. So yeah, up, and it should be null. A book principle, never heard of that. Okay, where's my first fail? Item.h. The first array fail is not array 1. It's correct. It's also not the first element of array 2, but it is the first element of array 2. second element of array 2. So if I add 2 more asserts, like, let's put these things, wait, I want to know for sure that it compiles, I was going to say. And it does, and we can run it, and it doesn't crash. It bloody crashes. Oh, never mind. Should do that. Oh, I just I keep it locked. So you keep it right locked, and then you suffer. Oops, that should work. Ding, 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 ding. That works. That doesn't assert. And I want to test it now without this stupid thing, because I'm just should be able to just put that right there, right? So a red constructed from array what element? So the same thing. Make no crash. Ding. And then we can duplicate it. It's way easier. So array 2, we're going to test the first element and the second element and the last element, because it has 3 elements. It's going to assert on this one. So this one is not going to assert, this one also not, but this one asserts. Yes? And you have a problem. That's not an assert, that's a core dump. Assertion failed, mutex data owner equals 0. What nonsense is this? Race condition. Now it deadlocks. Deadlock. 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 How the hell does this deadlock? I have one thread. Mutex. It's not that long. What is it? Does not have an owner. Does have a lock. Okay, what were you trying to log here? AI mutex log. It's not recursively locked. I would say maybe my mutex is destroyed in the meantime. What? No way. Line is 2, this and of course not. It doesn't make much sense, right? Maybe it's just memory corruption that did override my mutex. Now what? We're in this. Oh, oh, ah. Okay, anyone seeing this? What is the stupidity that I did here? You have 10 seconds. No, I'm testing array 1 instead of array 2. And array 2 has 3 elements, but array 1 has only 2 elements. So that's why it crashes here. It's just reading bullshit outside of the array. Yeah. Yep, that should have been array 2. And now you'll see that everything works perfectly. We're going to assert, yes. Bleep. We core dump in here, assertion field, and that is that line. The predicted line, yeah. So now we have an automatic test suit case thing. So I can just do that for every array. And then the only thing that is left is to make it work for all of it. That's array 3. And here we have array 4, which only has 2 elements again. Sorry. 3, so there must be 4. And then we get array 5, which has 3 elements. And array 6 with 3 elements. But of course it's still going to crash on the first one, this line. Now make that work, but not tonight. Let's go to bed after it compiles. Okay, I wish you a good night for now or in a few hours. And I'll be back to